This is AS Pure Maths. We're in Unit 4 looking at functions and graph transformations. So here is our example 1. It says a graph below shows a function y equals f of x. It looks like this. Use this graph to sketch y equals f of minus x. The fact that the minus is inside there means that it's going to affect things this way. And what the minus does is it effectively, the mirror line is the y-axis, and it effectively flips it over like that. So this point here is going to go to the point then minus 2, and the shape of the graph then is going to go like that. So let's get that one drawn on. So my point here is going to be minus 2, and everything is effectively a reflection of what we have above. And my new graph then looks like this. Again, that's the point minus 2. Part B, y equals f of x minus 3. So that's going to be the same graph, and remember this here is still inside the bracket, so it's affecting things this way here, and that's going to move everything to the right by 3 spaces. So this point, which is currently 2 minus 2, is going to turn into 5 minus 2. Everything else is the same shape. Let's draw it in here. So over 5 minus 2. Guess it's kind of unclear if this graph does continue on forever here, but that's what we're going to assume, I suppose. And it looks like that. Let's make that point nice and big. And then we're heading that direction there. And the final one is y equals 2 f of x. So that's a stretch. Everything gets twice as far away as it was then to the x-axis. So this now is going to become the point 2 minus 4, and everything just looks a bit more stretched this way. So down in my bottom graph here, it's going to be 2 minus 4. And let's get that drawn in. I guess it's good to show it maybe slightly more stretched. You don't have to, but I guess it gives more of an idea that we know what we're doing there, and that's that one stretched along from there. While we're at it, we'll look at the next week's section here. Graphs you should know. Y equals a over x graphs. These are known as reciprocal graphs. They have some asymptotes on it, so in these here it's kind of hard to see in this diagram because I guess computer generated, but this here is getting closer and closer and closer to the x-axis and never actually touching it. It's doing the same down here on the y-axis, same up here and same down here. So a real thing about thinking about asymptotes is that the line graph approaches a line but doesn't cross it. For vertical ones, how is that going to happen? If the graph then kind of looks, whenever the denominator equals 0, so when the denominator equals 0, a, for example, over x minus 2, you would get an asymptote at x equal 2, because whenever you sub in x equal 2 to this, we get 0, and you can't have 0 then the bottom of the fraction, so it becomes undefined. So that would be like this graph only moved across 2, and you would have your dotted line going down there. Horizontal, then it would be the x-axis. Because a over x can't equal 0. In terms of a y equals a over x squared graph, it is a similar look, but effectively this gets reflected up to here. So just a very quick sketch of that. Asymptote going this way, and then asymptote going this way, and then the other one, just a wee graph we should be aware of, is like an exponential graph. And they generally look like this. In this direction here, obviously that's your y-axis, and that's your x-axis, and this is generally the point 1 as well, because x to the power of 0 gives us 1, so whenever x is 0, as in this point here, it's always 1. Whenever x is 1, 2, 3, it just gets bigger and bigger and bigger and bigger and bigger. Remember, whenever x is a negative, a to the minus 1, a to the minus 2, it all means 1 over, so it's 1 over a squared, so it gets smaller and smaller and smaller, and you actually get an asymptote heading this direction here. So that's just some of those other graphs that tend to appear from time to time.